is Yanis Orfanos, and what I'm going to show is we don't have a startup yet, but we're in the phase of spinning out from this academic tool that I'm going to show. So, all of us know how important water is. Some will say that water is the new oil of the 21st century. But at the same time, there are many problems. There is water scarcity in many countries around the world, including the US. And this could be exacerbated by population growth and especially urbanization. At the same time, climate change is here, and it brings more drought and more sea level rise. Why we have to protect our water and our rivers from pollution that comes from the cities. But there's some good news. There is data, there is the Internet of Things, and technologies that can help us address these urban problems. But now we're in the phase to figure out how we can utilize this data. And especially about the water systems, what can we do better for their performance? One solution is to renovate and change the piping systems that they're under the ground. But this brings high cost. So what we'll see here is solutions that have to do with what can we do over the ground. And the answer is urban sustainable solutions. But the implementation is quite complex. It takes too much time. There are many processes involved, from consulting, designing, pre-designing, planning, the community engagement, decision-making, and the actions eventually. And all of us that have been in City Hall meetings or worked for design and planning firms, we know the degree of complexity, how much time does it take, and how different stakeholders have very different points of view. So, what if we can significantly reduce these processes, both in terms of time and quality? How we can provide better informed stakeholders and faster decisions? And at the Zofnas Program for Sustainable Infrastructure, the Harvard Graduate School of Design, we developed the UrbanWaterSystemsTools that I believe can provide some answers to the questions that I mentioned before. We did a lot of research, case studies in water systems across US cities in East and West Coast, and we identified the major challenges that these systems face. And we created a prototype for the city of Chelsea here in Massachusetts. And this prototype, this web tool, what is different from the other tools that exist already, were that these tools mostly are tools for experts, for engineers and planners. Our tool, the audience for our tool is non-experts. Our city stakeholders, like city managers, the developers, policymakers, and the community. And it has two main parts. One is learning the system of the city, and the second is what can we do to improve it. And now I'm going to show the demo. Okay. So here we can see very quickly for the city of Chelsea, first of all, learning the system. It has three components. The first one is the water system flow, that will provide some information about the architecture of the system, how the rainwater, the stormwater, the water supply, and the wastewater subsystems are interconnected, and also information about the main challenges. For instance, for Chelsea, is about reducing the runoff that drains to the Chelsea River, and also reduce the wastewater flows that go to the wastewater treatment plant in Deer Island. Second, there are visualization about the performance of the system that is quite important for small-sized cities who don't have the resources to provide these data-driven insights. And the third part of learning the system is information, geospatial information about the water system. And this is a collection of open data that exists in government, state, and city level, and we bring them all together. So that was information about the system. The second part is what can we do to improve it? And for the city of Chelsea, we identified these solutions: green roads, street planters, forest pavement, and water harvesting. And we give, information about the benefits, the co-benefits of these systems, of these solutions, and specifically, for example, for green roofs, apart from reducing the system flows, the stormwater, the runoff, and the wastewater, There are other co-benefits like air quality, benefits in air quality, in noise, in reduction of the noise pollution, energy use, etc. And the main thing here is the algorithm that we built that identifies in the city of Chelsea all the places that there are opportunities for sustainable solutions. For instance, which buildings can have green roofs, which streets there is enough space to add street planters, or parking areas that can have porous pavement, okay, and also water harvesting information, and we quantify the impact of these opportunities to the water system, how much the runoff is reduced, the imported water to the city, and the wastewater flows. And going back to the presentation, okay, and this is pretty scalable. We are already in discussions with other cities to apply the tool there, and of course, integrate other sustainable solutions that especially have to do with water conservation, like local water recycling units, high efficiency faucets, high efficiency washing machines, smart shower heads, landscape conversion, and quantify what if for other cities, these scenarios. And there are three key elements here. One is that this platform provides information about what are the solutions for a specific city. Secondly, quantifies the impact of these specific solutions to the water system. And third, a component that is not online yet in this academic tool, but that will be the heart of the business model, is to provide information about who provides these solutions, which companies and which businesses. And at the end, we will have this ecosystem of city governments and utilities that provide the data to the platform. They receive the insights, the businesses that provide the revenues, and also receive the insights and the connection to the city governments, and also stakeholders, developers, community, and other organizations that receive the insight, and they're pushing the government and the business sometimes in order to implement the solutions. And I'm close to the end. And of course, this scenario seems a little bit extreme, but to integrate everything together. But let's think that in 6-7 years, the cities, the way that we manage and we plan our cities will completely different. We'll have autonomous cars, and the data will be very central to that. And I believe that this platform will help us to prepare the ground for this. Thank you, and we'll be happy to answer any questions. What are the backend processes? Yeah, actually, one thing is we have collected open data and also received some extra data sets from the city of Chelsea. So it's information from MassGIS, from NOAA, from government agencies. We built algorithms that combines this data with statistics in order to quantify the performance. And also, we also use some formulas in order to cover gaps in the parameters because all the measurements are not here yet. Yes, please.
You only try to sell each product to cities themselves, city governments?
Yeah, can you please repeat the question?
We try to sell the product to city governments.
We don't want to sell the product to city governments because the city governments, it's not, the stakeholder that you will be beg. Huh? We offer the service to the city governments, but we want to bring companies, let's say companies that can provide high efficiency washing machines. And we're going to sell it to them, that in order to become part of this platform, they will give some money, and also they will give us the efficiencies and the data in order to quantify their solution to the system. And we're going to give the results to the cities. I hope I answered your question. Yeah. Please.
Josh with AmericanBlue.com. I just want to know how many cities
Online we have one city, and currently we're closing the collaboration. We're in the process with 4 more cities, 3 in East Coast and 1 in West Coast. So the progress will be much different than here.
One more question, please.
Yes.
How much? Oh, that's good. Go for it. You go for it. I know. Are you familiar with this? Recently, there was some legislation passed that requires a municipality or a city or town to find out where the runoff water goes. So what they have to do is run around, pour a dye in a drain, and figure out where it comes out. So could your system make? And they're required by law to do this. So that's why you need the catalyst you need to sell it to something like the city.
Yes, yes. And actually, EPA is going to force cities here in Boston in the Boston area to report all to reduce the phosphorus levels that come from the runoff by 2020, I think. Mm-hmm. And so this definitely is going to play a role in that and facilitate these processes.
Yeah. Okay.
Absolutely. Absolutely.
Thank you, UrbanWaterSystemsTool.